booth, as the banner shows, is seen here, radio frequency modulation. So what we have on the station just below there is hearing RF modulation. So I'm gonna hit a button, and you're gonna hear PSK 31, and on the monitor above it, you'll see the signal received. So this way people have the opportunity to hear what digital signals sound like, that there are characteristics.
We send high altitude balloons up to about 100,000 feet. We track them using amateur radio. We use APRS on 2 meters. This is one of our tracking devices. It's a GPS and an amateur radio beacon on board, transmitting packet. This will work. We've flown this twice. So to receive, we usually use, I've got a receiving system set up here. It's a little Yaesu and a computer with a TNC on board. The whole system runs off 12 volts, so it can be used in emergency use, mobile, in a car. So this is where we are, and this is a balloon that we have currently in the air. The altitude is 66,000 feet, and it's about 20 miles away from our location. I'm receiving with a simple antenna. It's up on a NVIS that we usually set up for field day. So this is one of our payloads. The different components get bolted to a metal frame, camera, and the tracking beacon, and then the metal frame gets tied on. We're required by the FAA to have a radar reflector, and then we also have a parachute, and then on top of the parachute we tie a 6-foot helium-filled weather balloon. We've done 12 launches so far, and we have a 100% recovery rate. We've gone anywhere from 80,000 to 105,000 feet in altitude.
This thing was basically. And Alex, why did you get involved in this?
We were bored. We were bored. We thought it would be a fun thing to do. We thought it'd be fun to play with APRS tracking and just be a fun project.
So I'm a licensed ham operator. My call sign is KJ6MVL. And so this is the PhoneSat project. So this is being built at NASA Ames. What we're trying to do is build a satellite for as cheaply as possible. So if you look in here, you can see that this is a Nexus 1 smartphone that we're basing the satellite design on. So the idea was to keep the hardware cost of the satellite for around $3,000, and we think we've done it. So we have the smartphone, we have some external lithium-ion batteries, we have a separate board, a watchdog board that uses an Arduino, and then we have a separate UHF beacon that works at 437 megahertz, and that's going to be sending down the health status of the satellite. Okay, so this is in the amateur band, and we're hoping that amateurs would help us collect the data. So really, all you need is something as simple as a handheld Yagi, like the one from Arrow Antenna, and an HT radio, and you can take the sound coming from the HT radio and put it into your sound card and decode the AX25 packets. So we're broadcasting at 1200 baud AFSK with the AX25 protocol, and so amateurs can listen to our satellite and help us get the data. So that's the amateur radio aspect of the project.
It's been 4 or 5 years we've been here operating portable on HF.
And what is the response from the people coming by?
It's incredible. It generates a tremendous amount of interest. The hams are everywhere, and it's great to have all the hams drop by and sign our whiteboard for 73s. And we pick up a lot of interest. We give out information on the local ham cram course, and we gave out all of our papers yesterday. We had to go get some more. So the interest from non-hams is tremendous here as well.
Great. And what is the one thing that they're really asking about?
In the Bay Area, the issue is earthquakes and emergency communications when we lose our power and cell phones.
Very good. And are you telling them that there's more to ham radio than just emergency services?
Yes, that's the social aspect and the inventive aspect. A lot of the people here are serious inventors, and it's interesting to talk to them about using the Arduino and other microprocessors to drive their radios.